It is a Sunday evening at the grocery store. You walk down the cleaning aisle for what feels like the fifth time this month. On the shelf in front of you sits a small bottle of Ceramite Glass Stove Top Cleaner, 12 ounces for $8.99. The label promises to remove burnt-on food. You pick up the bottle and squeeze it. It feels half empty already, and you bought this exact same bottle just 6 weeks ago. Beside it sits a competitor's version, $7 for 8 ounces. You stand there for a moment, look at the price tags, and add one to your cart with a small, quiet sigh. It is another year of paying $80 a year for soapy chemical pastes that come out of a plastic squeeze tube just to clean a single, flat piece of glass. Stop and think about that scene for a moment. Why do we accept this as normal? How did we become so dependent on specialized plastic bottles for every single square inch of our homes? How did we let the simple knowledge of our grandparents get replaced by expensive liquids that leave our pockets lighter? Now, step away from the supermarket aisle and walk into Esther's kitchen with me. Our wood-cook stove does not have a modern glass top. Old-order Amish kitchens like ours do not use modern glass cooktops. Esther's stove is made of heavy cast iron with a thick, dark black enamel surface. It is the exact same stove her grandmother cooked on for 60 years, enduring the daily splatter of lard and heavy iron kettles. Yet, if you look at it today, that surface looks as deep and clean as a mountain pool at dusk. The cleaning chemistry her grandmother taught her, the simple two-ingredient method that has maintained every cooking surface in our family kitchen for 4 generations, works on your modern glass stove top right now. It uses 2 things you likely already have sitting in your pantry or refrigerator, and it costs about 50 cents per cleaning. I want to be straight with you before I go any further. We do not use glass stove tops in our community. We never have. But the fundamental chemistry Esther's grandmother used on cast iron, enamelware, and porcelain sinks since the mid-19th century is the exact same chemistry that lifts stubborn grime off a modern glass cooktop. Honest folk chemistry does not care about the era your appliances were manufactured. It only cares about the physical laws of nature. I am Elias Yoder. I am an Amish farmer from Lancaster County, Pennsylvania. Today, I am going to walk you through this old 2-ingredient method so you can see plainly why it works, the specific technique, and the one common tool that most folks get wrong every single time, quietly ruining their expensive appliances. Understand this clearly. Before we talk about how to use this knowledge, we must establish the honest boundaries of where it belongs. This method is incredibly effective on glass cooktops, ceramic surfaces, and heavy enamelware, but it has strict limitations. You must never use this method on natural stone surfaces like marble or granite countertops. The mild acid will etch natural stone, leaving permanent, dull spots that no amount of polishing can fix. If your modern glass stovetop is recessed into a granite island, be exceptionally careful that no mixture runs off the glass onto the stone. Furthermore, keep it away from bare, unpolished aluminum as it causes dark, irreversible oxidation spots. We are looking for a clean kitchen, not a damaged one. Let us look closely at the 2 materials. The first is a fresh lemon. Any lemon will do. The cheap ones from the supermarket basket, or even a wrinkled lemon forgotten in the refrigerator for weeks. The lemon provides citric acid, a natural, weak organic acid. To the human hand, it feels like nothing more than fruit juice. But at a microscopic level, those acid molecules are highly active. They work by invading the stubborn bonds that hold congealed grease together, breaking them down from the inside out. They also react with hard white mineral deposits, the calcium and magnesium rings, that form when a pot of water boils over and bakes dry onto a hot stove surface. The second ingredient is a small box of baking soda, the same sodium bicarbonate your grandmother used for baking. When you pour it into your hand, it feels like a fine powder, soft as talc. Under a magnifying lens, however, baking soda is composed of tiny, sharp crystalline particles. These particles act as a gentle abrasive, providing just enough physical friction to scrub away charred food residues without being hard enough to scratch the tempered glass underneath. More than that, baking soda is mildly alkaline, meaning it sits on the opposite side of the chemical scale from the lemon juice. When these two substances meet directly on the surface of your stove, they react instantly. You can hear it before you see it, a sudden, sharp hissing sound, followed by a thick white foam that rises rapidly off the glass. This is the release of carbon dioxide gas. During this brief reaction window, lasting between 30 seconds and 2 minutes, the physical bubbling action does something manual scrubbing cannot do alone. It mechanically lifts the loosened dirt and grease particles upward, trapping them inside the white froth so they float safely above the glass. It is a beautiful, simple interaction of acid and base that farmhouse kitchens relied upon long before commercial chemical plants existed. We have the lemon, we have the baking soda, and we understand the simple natural science of why they cooperate. But there is a trap in this process. There is one specific detail regarding the cloth you use to wipe the surface that determines whether your stovetop stays beautiful for 20 years or becomes permanently ruined within 12 months. Most folks reach into their cabinet and pull out a standard paper towel, thinking it is the safest, softest choice for glass. They are completely wrong, and understanding why requires looking at how a paper towel is actually made. How exactly do we combine these two ingredients on a real, dirty stovetop without falling into that trap? And what is the exact sequence to ensure the glass emerges flawless and streak-free? Let us resolve that trap I mentioned before we lay a single finger on the stovetop. The choice of your cloth is the literal dividing line between protecting your kitchen and slowly destroying it. I want you to stop and think about what a paper towel actually is. It feels soft to your skin, yes, but paper is made from wood. It consists of thousands of microscopic, coarse wood fibers pressed together. When you press a paper towel against a flat sheet of tempered glass and rub it back and forth to scrub away grease, those tiny wood fibers act like ultra-fine sandpaper. You will not see the damage tomorrow, or even next month. But after a year of doing this every week, your stovetop will develop a permanent cloudy haze directly over the burners. That haze is not dirt. It is a dense field of thousands of microscopic scratches reflecting the kitchen light unevenly. No chemical cleaner can remove it because the glass itself is worn down. The only remedy then is a costly replacement. To avoid this, you must use a clean microfiber cloth or a piece of an old, well-washed cotton bedsheet. Synthetic microfiber or aged cotton fibers are completely smooth at the microscopic level. They are softer than the glass, meaning they can lift the grit away without ever biting into the polished surface under your pots. Now that we have the proper tool in hand, let us look at the condition of the stove. The first rule of traditional kitchen chemistry is patience, and that begins with temperature. You must never attempt this method while the stovetop is still warm from cooking. If the glass is hot, the citric acid in the lemon juice will evaporate too quickly, causing the acid to bake directly onto the surface. This creates stubborn, cloudy streaks that are far more difficult to remove than the original burnt-on grease. Take the back of your hand and hold it an inch above the glass. If you feel no rising heat, gently touch the surface. It must feel completely cool to your touch, just like a stone pulled from a shaded creek. If it is room temperature, you are ready to begin. The first step is the dusting. Take your small box of baking soda and shake it gently over the cooktop. I do not want you to dump it in heavy piles or thick mounds. Instead, think of a very light, dry winter snow falling across a country lane. Walk your hand across the surface, letting the powder sift between your fingers until you have a thin, even white layer covering every single square inch of the glass. Ensure you cover the outer edges where grease splatters tend to settle, as well as the dark rings directly over the heating elements where boiled-over liquids have baked into hard crusts. If you have a particular spot where a pot of oatmeal or sugar water boiled over and left a thick, black, raised scab of carbonized food, you may add a slightly heavier pinch of baking soda directly onto that specific blemish. The powder should look soft, dry, and perfectly uniform. Next, take your fresh lemon. Place it on a clean cutting board and cut it directly in half across its middle, right through its equator. Do not cut it lengthwise from stem to tip. Cutting it across the middle exposes the maximum number of open juice cells across a wide, flat, circular face. As the blade passes through, you will immediately notice the sharp, bright scent of essential citrus oils filling your kitchen. It is a clean, honest smell that completely cuts through the heavy, stale odor of old cooking grease. Now we begin the physical application, and this is where the traditional method truly shows its worth. Take 1/2 of the lemon and place the wet, cut face flat against the dry layer of baking soda in the center of the stovetop. Press down with just enough pressure to squeeze a small amount of juice into the powder. The very instant the liquid meets the sodium bicarbonate, you will hear a sharp, lively hissing sound. Look closely, and you will see a thick, creamy white foam rapidly bubbling up around the edges of the lemon. This is the chemical reaction taking place, releasing carbon dioxide gas and physically loosening the debris. Move the lemon half in small, deliberate circular motions across the glass. The lemon half itself is now your scrubbing tool. The soft pulp and the flexible inner rinds of the fruit act as a natural, non-abrasive pad, gently pressing the fine baking soda particles against the stubborn grime without any risk of scratching the glass. As you move from one burner to the next, squeeze the lemon slightly firmer to release a steady stream of fresh juice, feeding the white, hissing slurry beneath your hand. If you encounter a dry patch where the powder has absorbed all the liquid, do not rush. Simply add a small sprinkle of fresh baking soda. Squeeze the lemon again and watch the bubbling foam renew itself. Spend about 3 minutes working your way across the entire surface, paying extra attention to the dull patches around the high heat areas. You will notice the color of the foam beginning to change. It will turn from a pure, snow white to a dull, murky gray or yellow as it pulls the suspended oils and charred carbon particles out of the glass and holds them in the liquid suspension. Once the entire surface is covered in this damp, bubbling cream of lemon juice and baking soda, stop. This is where most beginners make their second mistake. They try to wipe it away immediately. Understand this. The chemistry needs time to do the heavy lifting so your muscles do not have to. Walk away from the stovetop for a full 15 minutes. During this window of rest, the citric acid is quietly working on the microscopic level, softening the tough, baked-on mineral scales from your water and breaking down the complex lipid bonds of the old cooking fats. The baking soda is absorbing the dissolved grime, drawing it away from the smooth glass underneath. Go pour yourself a cup of tea, look out the window, or wash a single drying dish by the sink. Let the elements do the work they have done for over a century. When you return after 15 minutes, you will see that the high, active fizzing has completely subsided. The foam has settled into a quiet, dull, semi-dry white paste that holds the trapped dirt within its structure. Take your clean microfiber cloth and submerge it in a basin of warm water. Wring it out thoroughly so it is thoroughly damp, but not dripping wet. To remove the paste, do not scrub. The scrubbing is already done. Instead, place the damp cloth flat at the back corner of the stovetop and pull it toward you in long, slow, steady vertical strokes. As the microfiber glides over the surface, it will lift the heavy layer of baking soda slurry and dissolved grease away in a single pass. After 2 or 3 strokes, your cloth will be full of gray residue. Stop, rinse the cloth completely clean in your warm water. Wring it out well, and repeat the long strokes across the remaining sections of the glass. You will need to rinse the cloth 3 or 4 times to ensure every single fine grain of baking soda is completely removed from the kitchen counter. When the final trace of moisture evaporates from the glass, stand back and look at the surface from an angle where the kitchen window light catches it. You will see a perfectly clear, deeply reflective surface without a single oily smear, a single chemical rainbow streak, or a single scratch. It is the exact same clean, deep shine that Esther's grandmother expected from her porcelain and enamelware every Saturday morning, achieved without a single synthetic chemical or a single costly plastic squeeze bottle. Now, let us step back for a moment and look behind that white foam. To truly master a traditional craft, you cannot just memorize the steps like a recipe in a book. You must understand the underlying laws that govern the materials. What we are witnessing on the stovetop is not a magic trick, nor is it some mysterious folk superstition. It is steady, unyielding science, working exactly the way the Creator intended. Understand this. Nature operates on a system of balances, much like an old iron seesaw sitting in a schoolyard. On one side of this seesaw, we have acids. On the other side, we have alkalis, or what modern folks call bases. Left alone, each side has its own distinct properties and strengths. But when you bring them together in the proper measure, they create a temporary storm of activity before they settle into a state of perfect balance. Let us look first at the half of the lemon in your hand. The juice inside contains citric acid, which is a weak organic acid. To your fingers it feels thin and harmless, but to a layer of grease it is a formidable force. Stop and think about what cooking grease actually is. On a microscopic level, grease is made of long, tightly defensive chains of fat molecules that cling to each other and to the glass surface like a tangled mat of briars. The citric acid acts like a sharp steel wedge driven into a seasoned oak log. It forces its way between those fat molecules, snipping the chemical threads that hold them together. Once those chains are broken into smaller, weaker pieces, the grease loses its grip on the glass and can no longer resist being wiped away. At the same time, that mild acid is performing another quiet task. The white, crusty rings that form around your burners are typically made of calcium and magnesium, minerals left behind when hard water boils over and evaporates under intense heat. These minerals are alkaline by nature. When the citric acid touches them, it doesn't just scrub them. It enters into a chemical reaction that converts those solid, rocky mineral scales into soluble, neutral salts. It is the exact same principle that causes vinegar to clear the white crust out of an old iron tea kettle. The solid stone ring simply softens and dissolves into the liquid, leaving nothing but clear glass underneath. Now let us look at the other side of our seesaw. The baking soda. Sodium bicarbonate is a mild alkali. When it comes into contact with the greasy acids left behind by cooking oils and animal fats, it performs a very old chemical transformation. It mimics a process that traditional homesteaders call saponification, the very same reaction used to make soap from wood ash and lard. On a very small scale, the alkalinity of the baking soda converts a portion of the stubborn stovetop grease into a crude, water-soluble soap right there on the glass. This is why the mixture begins to feel slippery under your hand as you scrub. Furthermore, we must look at the physical shape of the baking soda itself. Even though it feels as soft as flour between your fingertips, it is actually made of tiny crystalline structures with flat, sharp edges. Because these crystals are composed of sodium bicarbonate, they are physically softer than the tempered silica glass of your stovetop. Think of it like using a pine block to scrape dried mud off a piece of iron. The wood is firm enough to dislodge the mud, but it can never scratch the harder metal beneath it. The baking soda crystals roll across the glass, mechanically shearing away the raised scabs of burnt food without leaving a single permanent mark on the polished surface. The real wonder, however, happens when these two opposites collide. When the liquid citric acid from the lemon meets the solid sodium bicarbonate on the stove, they immediately rush to neutralize one another. This sudden meeting creates carbon dioxide gas, which is what causes that sharp hissing sound and the eruption of thick white foam. I want you to visualize this bubbling action, not just as a visual show, but as thousands of tiny microscopic crowbars. As the gas expands and forces its way out of the liquid, the bubbles wedge themselves underneath the loosened particles of dirt and carbonized food. They physically lift the debris upward, popping it off the glass surface and trapping it within the walls of the foam. The reaction does the heavy lifting for you, suspended in the froth until your cloth comes to take it away. But I must be entirely transparent with you about the limitations of this method. Honest folk chemistry has strict boundaries, and if you cross them, you will cause costly damage to your home. This two-ingredient mixture works beautifully on glass, ceramic, stainless steel, porcelain, and heavy enamelware because these materials are chemically inert and harder than the baking soda crystals. However, you must never, under any circumstances, use this method on natural stone surfaces. If your kitchen features countertops made of granite, marble, limestone, or travertine, keep the lemon juice far away from them. These natural stones are held together by calcium carbonate. Because citric acid dissolves calcium, dropping lemon juice onto a polished marble countertop will immediately etch the surface. It will eat into the stone within minutes, leaving behind a permanent, dull, cloudy spot that looks like dry chalk. If your glass stovetop is set into a stone island, you must be exceptionally careful. If even a few drops of the lemon juice run off the edge of the glass and pool on the stone, the polish will be ruined. Always shield the surrounding stone with a thick, dry towel before you begin. You must also exercise caution around bare, unpolished aluminum. Many modern glass cooktops are framed by a thin metallic trim. If that trim is made of anodized or bare aluminum, the citric acid will react with the metal, causing a rapid oxidation process. This will leave permanent, dark gray or black chemical stains on the metal trim that no amount of scrubbing can remove. Keep the mixture strictly on the glass surface. Finally, there is a safety boundary that you must respect for the sake of your household. Never mix this lemon and baking soda solution with commercial bleach or any product containing chlorine. While our traditional ingredients are entirely safe on their own, mixing any acid with chlorine bleach creates a chemical reaction that releases toxic chlorine gas into the air. Traditional methods rely on the simplicity of nature, not the mixing of modern industrial chemicals. Keep your cleaning honest, keep it separate, and respect the natural limits of the tools in your pantry. When you stand back and look at that clean surface, catching the gleam of the evening light without a single chemical smudge, you are looking at something deeper than a clean appliance. You are looking at an inheritance. This simple wisdom did not drop out of the sky, nor did it originate in a corporate laboratory, where scientists package solutions into plastic bottles designed to be emptied and replaced every 6 weeks. It was forged in the demanding reality of early American farmsteads, where resources were hard-won, waste was considered a failing, and every household material had to earn its place in the pantry. To truly understand where this chemistry came from, we have to look back to the middle of the 19th century. In the 1840s, when commercial sodium bicarbonate first became widely available to American households, it was not marketed as a specialized cleaner. It was simply a raw mineral salt kept in a plain wooden firkin or a simple paper sack. The farmwives of the Pennsylvania Dutch country, practical, observant women who managed massive households with zero electricity, immediately recognized its dual nature. They saw that it could make their bread rise in the brick oven. But they also noticed that when mixed with the juice of sour fruits or the cider vinegar fermenting in their cellars, it possessed a remarkable power to lift grease from heavy ironware without pitting the metal. Understand this. These women did not have the luxury of choice. A farmhouse kitchen in Lancaster County in 1860 required constant, heavy labor. The wood cook stove ran continuously from October to April, accumulating a stubborn layer of carbonized soot, grease, and ash that would choke the efficiency of the iron if left untamed. They cleaned their enamelware basins, their tin baking pans, and their deep porcelain sinks using the exact same bucket of baking soda and whatever mild organic acid was at hand. If a lemon could be bought from a traveling dry goods wagon, it was treated as a precious tool for the finest polished surfaces. They did not view cleaning as an act of purchasing a specialized product for every distinct room. They viewed it as the masterful application of a few unchanging physical laws across the entire homestead. This traditional knowledge was not just handed down by word of mouth through the generations. It was thoroughly tested, verified, and documented by the early pioneers of domestic science. If you look back into the historical archives of the United States Department of Agriculture, specifically the classic farmers' bulletins published in the early decades of the 20th century, you will find this exact chemistry laid out plainly. Publications like Farmer's Bulletin, number 1180, titled House Cleaning Made Easier, were written by home economists who went out into rural communities to evaluate traditional methods against the rising tide of commercial industrial powders. The government experts arrived with their scales and our testing sheets. And what they discovered confirmed what the farm wives already knew. The bulletins explicitly warned rural homemakers against buying expensive, heavily advertised commercial scouring powders, noting that many contained ground quartz, feldspar, or volcanic ash. While these harsh minerals cleaned quickly, the bulletins proved they permanently scored the delicate glaze of porcelain sinks and the smooth finish of new enamelware. Instead, the official government recommendation was to use sodium bicarbonate and mild organic acids, certifying them as the safest, most effective non-abrasive agents available for protecting high-value household surfaces. Stop and think about that for a second. More than a century ago, official research proved that the simplest materials in the pantry outperformed the harsh, expensive alternatives. And that verification has never changed. If you look at the modern educational resources published by university extension offices today, whether it is the Kansas State Research and Extension Sheets or the bulletins from Michigan State University Extension, you will find their family wellness agents still teaching the exact same lesson. Modern science confirms that baking soda has a remarkably low rating on the hardness scale, meaning it is physically impossible for its crystals to scratch the tempered glass-ceramic blend of a modern cooktop, even under heavy hand pressure. The traditional chemistry has stood up to every wave of industrial scrutiny. Yet, despite this mountain of historical and scientific proof, the simple old chemistry sits quiet in farmhouses like ours. While the cleaning aisles of modern grocery stores grow longer and more expensive every year, there is a simple reason for this silence. There is no profit to be made in teaching you that a common fruit and a kitchen staple can solve your problems for 50 cents. The industrial household market relies on creating a sense of complexity, making you believe that your glass stovetop requires one specialized liquid, your stainless steel refrigerator requires another, and your porcelain sink requires a third. They sell you back your own independence, packaged in a sequence of brightly colored plastic squeeze tubes that litter your cabinets and drain your household budget. You do not need to participate in that cycle any longer. You can choose to be the person who stops paying for the illusion of specialized chemistry. The old ways are not backward. They are simply efficient, grounded in a time when folks knew how to look at a problem with their own eyes instead of looking at an advertisement. So, here is my invitation to you tonight. When the dinner dishes are washed and the kitchen grows quiet, let your stovetop cool down completely. Walk to your pantry and bring out that simple, familiar box of baking soda. Cut a fresh lemon in half. Smell that clean, honest citrus oil as it fills the room, and follow the steps we have laid out. Sprinkle the white powder like a fine dusting of snow. Move the lemon half in those patient, steady circles and listen to that lively hissing reaction. Let it sit while you rest, then wipe it clean with your microfiber cloth. Watch the glass emerge beneath your hand, deep, clear, and completely free of commercial film or chemical residue. When you see your own reflection in that polished surface, understand that you have not just cleaned a stove. You have recovered a piece of forgotten self-reliance. You have proven